Did everybody get a chance to copy the files? Did everybody download C++?
Yes.
Yes? Excellent. Good. Okay, so I want to begin today by reviewing the logic. You know, how does this all work? Excuse me. So the idea is that we have some problem that we want to solve. Right? Is that the computer? Okay. So time to get up already? Okay. We have some problem we want to solve. We have to know what it is. So let me just back up for a second and remind you something we discussed in 140 class. And it's really important. I think that Andy also discussed it with you in the 208 class a little bit. Knowing how to solve a problem sometimes is the easy part. The hard part is knowing what problem it is that you need to solve in the first place, especially when it comes to design. Right, so now in the 140 class, everybody's part of a project team, and you're going to propose these new projects, how to make the world a better place. That could be the very difficult part, is figuring out what it is you want to solve in the first place, not how to solve it. So there really is another step back before this one, maybe, which is that you understand what it is that you should do. But let's assume that we know that what we want to do is solve some problem. So I used this example yesterday, I used the same example today. Suppose that we need to calculate the sine. And we want to put our input in degrees, and we're going to calculate the sine. Okay, in computer jargon, this is also sometimes used in mathematics, but especially if you talk to computer programmers, the people that have to solve real problems, they use this word a lot, algorithm. Who knows that word? Have you heard that before? A few of you, but not many. So it's kind of a specialized word in mathematics, and it has to do with the logic of the solution. Right? What is the logic or the procedure of the solution? It's not the actual solution. It's just, do I understand the steps, the process that will enable me to get to the answer? So in this case, our algorithm, we could say, really only has two steps. Right? The first step would be convert into gradients. And the second step is to calculate this series. Right? That's the algorithm for solving this problem. Now, as you get farther and farther along into more advanced courses, more advanced engineering, you might have an algorithm that has tens of steps, hundreds of steps, even thousands of steps. Just the logic, not the program. Just the logic of how it is that you get to the answer. I also made a comment the other day that I've had a pretty good career. I'm happy with it. A lot of my career has been based on my ability to create working algorithms for problems that other people didn't solve. So the logic of how to get a solution for a lot of problems can be very difficult. So algorithm development can be a very, very crucial step. But in this case, we've got our algorithm. Okay, so what's the next step? Well, if we were really smart or else really stupid, maybe, one or the other, we might skip those two and just go right to the machine level language and start writing a crazy number of ones and zeros and logic and stuff like that to actually use the hardware in the computer. Okay, and almost nobody's going to do that. It's too difficult. So the next step then is to take this algorithm and write the actual language that the computer, you can put into the computer to make it do what you want it to do. Okay? And then there's a key word here, I should have written down. Very, very good, important word to know that shows up in your notes. Syntax. Syntax is critically important because when I speak Vietnamese, I certainly don't speak it very well at all. I can come in and say, "Xin chào." You have some idea what I'm saying, but it's not really right. It's because you're a human and you're intelligent. Even if I don't say it quite right, you know what I mean. And sometimes when you speak to me in English, you don't say things perfectly, but I know what you mean. The computer doesn't have any of that. The computer is an idiot. You have to say it exactly right, or it can't do it. Okay, like for instance here, if I wrote, instead of the 360, if I put the 2 here and the 360 here, if I tell you this is a person, you would look at that and say, oh, you got that backwards. The computer doesn't care. The computer will calculate this. It's fine with it. Right? It has no logic, no intelligence. It does exactly what you tell it to do. So you have to make sure you tell it exactly what you want it to do. That's the idea of syntax. So we're going to go through a lecture in a few minutes. We'll talk about debugging a program. The debug step can be critical because two things happen that can drive you crazy. The first one is you write a statement that looks totally normal to you, and the computer keeps telling you the statement doesn't make sense to me. Okay, because you made one syntax error. Maybe you put a period out here or something like that. In your mind, it doesn't change anything. In the computer's mind, if it's not perfect, I don't understand it. And so it tells you this statement is invalid. I can't calculate this statement. I can't process this statement. And you look at it and it looks perfectly fine to you. It drives you crazy. Okay? That's a syntax problem. You've written a statement that the computer just can't understand. Okay, now another kind of problem that can be much worse is you write a statement that the computer understands perfectly. It understands that statement. But you got it wrong. It's not doing what you want it to do. Those are also mistakes that can drive you crazy. And those are much harder to figure out because the computer will calculate it. No problem. It'll calculate this number, but it's the wrong number. Then when it calculates this series, you don't get the right sign. And so here you're trying to make this simple calculation to just calculate the sign of the number, and it doesn't work. But the computer isn't giving you any error message. It's calculating. Every time you give it a number, it calculates. But it's not calculating the sign. And so you have to study and study and study. You go crazy just looking at the logic. So there's both the syntax, and there's also logic. And you have to debug your program. You know what a bug is, right? What's a bug? It's a little crawly thing, they're annoying, right? So inside of a computer program, if there's anything that doesn't work quite right, it's called a bug. And to get the computer to finally do what you want it to do, you have to debug it. Right? If you de something in English, it usually means you remove it. Debug, get the bugs out. Okay. Alright, so now you've written this language. Now you put this language into a piece of software that exists on the computer that does this really tedious job, this very difficult job, boring, hard job of converting something that looks like this into a whole bunch of ones and zeros that the actual hardware level of the computer can do something with. So this step is also a crucial step. And this is a software step, the compiler. So the compiler you're learning now, you're just starting to learn, is called C++. And it's not the only one. For a very long time, probably at least 20 years in engineering, starting from maybe middle of the 1960s to the middle of the 1980s, something like that, probably 90% of all computer and engineering was done using a compiler called Fortran. Who's heard of Fortran? Okay. I finished my PhD in 1985, and at that time, I never used another compiler. My entire career was nothing but Fortran. Okay, now in this class, you're going to actually use two if you count MATLAB. MATLAB is sort of like a separate compiler. So if you're going to use C++, we won't use Fortran in here, but Fortran was it for a long time. Okay. Fortran had a lot of versions. So the earlier versions were almost impossible to use, and then it got slowly easier and easier. But eventually other programs came along that were even easier. So a lot of it has to do with how much does the language here that you are allowed to use make sense to you, and how close is it to a bunch of ones and zeros that don't make sense. So the earlier versions of Fortran, this distance in between these two was a lot smaller than in the later versions. So in the earlier versions, you had to write a lot of statements that just didn't look like any words that you ever heard of. And frankly, I think C++ still has a little bit of this problem. As we start writing statements, which we're going to do today, we're going to start to write programs today. Some of those statements that do things, the wording in the statement's not really so obvious. It's not really obvious why you do that. Okay. Any questions about it? So I think it's really helpful to see the overall structure of what it means to be doing programming. So if you hear somebody say, "I'm a computer programmer," what exactly are they doing? Pretty much just from here over. Okay. A lot of engineers do everything from here over. Some engineers do only things from here to here. Right? Then they give it away to somebody else, and somebody else does here to here. It's really up to you what you're interested in and how good you are. Maybe you're really good at this and you really like it, so you concentrate on this part. Maybe you suck at this and you hate it, so you concentrate on this part. Now, I want to back up again for a second and just talk about this course. The course has 4 main chapters, 2, 3, 4, and 5. You'll have them all electronically. Chapter 2 is all about C++. Chapter 3 is about Microsoft Excel, right? I have some mixed feelings about whether it's such a great idea, but Excel is a very useful program for relatively simple calculations, and for a lot of use, you don't need to do anything more. So it's a good enough program to do a lot of things with, so it's probably worth learning. But you can learn it in a lot of different ways. I don't know if it really makes sense as part of an engineering class, but how's the engineering curriculum set? How do we set the curriculum for the courses? All the faculty get in a room, discuss, vote. Okay, so just because I don't agree doesn't mean it doesn't happen. I don't always win the votes. Okay, so I probably, if it were up to me, I probably wouldn't bother to put Excel in this class. But it's in this class, and we'll do it. Then the third part of this class, maybe the part that sounds really strange to you, the chapter 4 part, is something called numerical analysis. All right, what is numerical analysis? In numerical analysis, we're really going to be right in here. That's when we shift from this part over and do some of this part. Okay, and why do we do that? There's kind of one simple way to imagine this. Think about it. Humans have been much better at discovering mathematical problems than they have been at solving them. So in the math classes that you've taken so far in your career, most of the problems that were proposed to you in those classes also had a solution. So as part of the class, you learned the problem and then you learned how to solve the problem. But in fact, in real life, there are a lot of very important problems that nobody's figured out how to solve yet. Exactly. But people have figured out algorithms that enable them to calculate something that you can prove is pretty close to the solution, even though you don't know what the exact solution is. Okay? And this actually would be a simple example. We talked about this the other day. I can't actually calculate the sine. To do that, I would have to calculate this series out to infinity. Well, I'm not going to calculate it out to infinity. At some point, I'm going to cut it off. Okay? So I'm not making an exact calculation. If it's not exact, it's called numerical. I'm representing the solution with numbers only, not with an expression. Okay? So that's the idea for the chapter 4 part. Now, chapter 5, when we get to MATLAB, in my opinion, is the most important part of the class. So it's nice that it comes at the end and we build up to it. MATLAB is a program that, on the surface, looks a lot like C++. But after you learn C++ and you start using MATLAB, you'll see that MATLAB has a lot of nice features in it that make it easier to use than C++. Some things that you have to do for yourself in C++, MATLAB will do for you automatically. Okay, so that's how the course is put together. I welcome, this is a kind of side comment, but I welcome you to ask me questions about the whole point of the course at any time, right? Or any piece that we're doing. I think it's good for you to imagine. Try to have a big picture. You have to learn details, but also always keep the big picture in mind. What's the point of this? Why should I bother coming to class? So I'm trying to explain to you how this course is put together and why it makes sense in a big picture. Please don't hesitate if you have a question to ask. All right. Did everybody look at chapters 1? Look at the lectures for 1.1, 1.2, 1.3, 1.4, and 1.5. Everybody did all that. Excellent. Did everybody do exercise 1.1? Yeah, using FileZilla. Yeah, I'm not a FileZilla expert, so why don't you, if you don't mind, maybe email me that question so I can look at it in slow time. Yeah, maybe we can do that next time. But the most important thing that you might be missing is you need to have a destination on a remote computer. So if you're not linked, if you don't have permission for somebody else's computer, then there's no reason to use FileZilla. It's sort of like if you want to send a file by email, you have to know the other person's account or you can't possibly send it to them. But FileZilla is a level above that because you have to have permission like a separate account on somebody else's computer to make that link. Okay?
I already have the account on the internet web page.
Okay.
And if I send that something, I've got something in this they're posted when
Yeah.
do on the web.
Well, I can try to help you with FileZilla, but the details of how we transfer files from one place to another in this class are not really that important. So I mean, we can transfer them by email, we can transfer them by thumb drive. So I don't really care actually whether you use FileZilla or not. It doesn't matter to me. I know that on the UP campus, this course often is huge. It might have 150 or 200 students, and they use Dropbox. Does anybody here use Dropbox? I've used Dropbox a few times. Yeah, so that's another commercial program that I can't really explain how it works. I don't really know very well, but I have used it. And the main advantage of Dropbox, which is like FileZilla, if most email programs limit the attachment to 25 megabytes. In Dropbox, somewhere out in the web, I have no idea where, somewhere out in the ether universe, somebody has a big file system, a big hard drive, and you can have access to deposit huge files on there, gigabytes of files if you want. And then you can give other people the same access so they can come and download those files. So it puts this location called Dropbox in between you and the other person. It's not really direct transfer. You drop it in there, and somebody else can come and take it out. I don't really know how it works, but it works. So, yeah. I bought a new digital camera last year that has HD video mode. Anybody else have an HD video camera? The size of the files is ridiculous. Like I think a 1 minute video is something like 300 megabytes. It's ridiculous. So it's nice to look at. It looks good. And if you don't have to try to send it to somebody, it's okay. You can watch it on your computer. But if you have to give it to somebody else, then it gets really ugly because it's so huge. So I wanted to transfer some videos to a friend of mine, and that's when I learned how to use Dropbox. All right. So I think what we'll do then, I want to look at chat. I'm sorry I don't remember off the top of my head. Are all those files on here, Alex? All of the course files? Where would I find them? I just want to Did anybody bring a thumb drive or something like that with the course files? Okay. You can go there. You can find out through. Okay, while he's working on that, let me ask the rest of you a question. Yesterday I talked about variable types, right? And we talked about truncation error, round-off error. So in C++, I used the term yesterday, a regular number. There's two kinds of this in C++. What are they? Yeah. So this was in the material that you were supposed to read. So who can remember what the two kinds are? Maybe this is at the beginning of chapter 2, so maybe you can read this one. Okay, there's integer, that's a separate type. There's also character that we talked about. And one other I didn't mention yesterday because I never use it, and the author of the book also says he never uses it. There's something called a Boolean. two kinds of regular numbers, and they do have specific names in C++. One is called float, and who knows now? That's a hint. Anybody know what the other one was called?
Yes.
The other one was called double. Okay, so float, this stands for a floating decimal point. This is the system the computer uses so that it can always store a certain number of digits, no matter how big or how small the number is. So it's what it stores is, for float, it stores 6 digits, and then for the power 10, it stores an exponent. And the exponent, I don't know in C++, it's probably limited to 2 digits. Okay? So for instance, if I were going to store the number 428,963,156, let's say I want to store that number. Okay, what actually gets stored in C++, if that variable type is called a float variable, what would get stored here would be 428,963. This stuff gets completely lost. And up here we have 0. Well, yeah, I guess it depends on where the implied decimal point is. And I'll be honest, I'm not sure in C++ whether they put it here. That's typical. Typically, you put it either there or there. I don't really know. So if it were on this side, then it would be 10 to the 10. And if it's on that side, it would be 10 to the 9. Okay? Any questions about this? All right, so there's a syntax statement, a kind of statement inside of C++ called an assignment statement, which is very common. You'll be using it a lot. So maybe inside of your assignment statement, you had something that said x is equal to 428,963,156. That was your assignment statement. This is what C++ will store. That's what it makes out of that. And the area inside the computer, the actual hardware area inside the computer where that's stored, gets a name. And the name for that area is X. Okay? You can name it whatever you want. You could name it, I don't know, 10. Anybody have the English name 10? It's a common boy's name. Yeah. What's that? No, my son's not Ted. Okay, Ted could be the name. Then this would have the name Ted. Totally up to you. Okay? Alright, let me change it a little bit. Suppose that you put in, instead of 1 out here, let's say we put 5 out here. Does anything change?
No. 6 digits.
Okay, it's still 6 digits, but now this is more than half.
Yeah.
So C++ will store a 4 here. Everybody understand that? It stores a 4 there. Okay. Round off, yeah. So there's 2 types of error. One is called round off. The other is called truncation. When the value is stored by truncation, it counts over 6 digits and just chops off the end of it. And so in that case, for truncation, this would be 3. Round off, it goes to the nearest number in the last position. Okay? So that's the difference between round off and truncation. Both of them are potentially a problem for you, especially if you have a very long algorithm with a lot of steps. So you keep calculating stuff over and over and over and over again, maybe millions of calculations, and every single calculation has some little bit cut off at the end or rounded off at the end. So for 1 or 2 cycles, it doesn't matter that much. But after a million cycles, maybe the answer is no longer has any meaning. Maybe it's completely wrong. I gave you that example yesterday. 10 million plus 1 minus 10 million is equal to 0. Okay, that's a big problem. 0 is a lot different than 1. The right answer is 1. The computer stores 0. Okay, any questions about that? Now, I also told you that in the earlier days of computing, the reason why there was a limited number of spaces is because there was a limited number of memory. Memory was very precious, right? How much memory did I have on my first computer? 64K. K. Not M, not G, not T, 64K. Alright, so if you knew that you were going to have a problem by having the numbers be too small, and you could have enough memory to allow it, then they created a new type of regular number. It's called double. Okay? The way that C++ stores double is 12 digits. So float uses 6, double stores 12. So if I put this same statement in, and I told it it was a double, this is what it would store for a float. And for a double, it would store 4289635560000. A total of 12 of these. The same size for the exponent. Okay. Now, in these days, I don't think anybody ever uses float anymore. You would have to have a huge number of variables in order for 12 digits to be too many to store, because the storage is nowadays so inexpensive. All right? Any questions about that? Fortran had exactly the same idea. The first versions of Fortran stored 7, not 6. Fortran also had double. Double in Fortran was 16. Okay, it's kind of strange looking, I know, but there's a subtle explanation for why that happened that way, which I won't try to duplicate the explanation. Then Fortran invented something called quad. This is not in C++, but just as an aside thing, Fortran invented something called quad, which was 2 times double. Quad had 32. 32 digits. That's a long way from 6. That potentially is a lot more accuracy. Especially if you're making millions and millions of calculations. When might you make millions and millions of calculations? Well, lots of reasons, and you'll have some of those reasons coming up later in the semester, later in this course. Okay. Yeah.
Why is that C++ is advanced from Fortran? Because I see the differences on the float number is 6 and Fortran is 7. What is the advantage of?
It had to do. I'm not a compiler writer. I'm a compiler user. So I'm not sure exactly why C++ had 7 and C++ had 6. Fortran had 7. I don't know the explanation. But this double precision Fortran, what was called double precision, had 16 digits. And in C++, double only has 12. And I think that's a big reason, one of the big reasons why all of the serious engineering software for a long time was Fortran. C++ was not normally used at the highest levels of computation. Okay, then we talked about integer last time. We talked about character last time. Right? In this screen right now, there's something up here that is a character. What is it? What is that? Yeah, right? This name, Ted, somewhere down at the machine level, the T is a bunch of ones and zeros, so is the E, and so is the D. It's just some other pattern of ones and zeros. But that pattern is not supposed to be interpreted as a number. It's just supposed to be interpreted as a picture, really. That's all a character is, right? That's all an alphabet is a picture. Especially the Chinese alphabet. How many of you have studied much about the Chinese alphabet? The Chinese alphabet is literally a bunch of pictures. It's a little tree, a little guy standing next to the tree, it's a house. That's how it started out, that's what it is. Now, nowadays, they made it a little bit easier to write, so the pictures aren't so easy to recognize as the old ones. But that's all they are, they're pictures. What does the Chinese book say? It says tree, house, pig, tree, house, pig, tree. You know, it's just a bunch of little pictures. But of course, you have to know how to interpret it into words. So what does this say? These are just little pictures. You know, what's a T? It's just a picture. Tree, maybe. What's an E? I don't know, a frog with his mouth open. Who knows? Okay. So the computer allows you to store those characters. That's Ted, would be a character. Is there an integer up here? It's probably not so obvious to you, but the exponent on 10 is always stored as an integer. It can't be 8.5. It has to be 8 or 9 or 7. Because all it does is it tells you where that decimal point goes on the actual number, how far to move it to the right or the left. That's what this tells you. And it can only move by one place at a time, or by 2 places, or by 3, but nothing in the middle. So this is an integer. And the exponent part is an integer. And like I said, Boolean we're not going to worry about. Boolean is logic. These are logic variables. This is a real pain in the neck. Notice I didn't say pain in the neck means the same thing as pain in the ass, but it's less. Okay. So Boolean, though, is used for logic. So one of the things that we're going to have happen very soon in the lectures you're going to see is we're going to get into these logic statements like if, or while, or then, or else. Okay? And that's really common if you're going to write a good program. Is to have, for instance, an if statement. So you start coming down through the calculation, and you get to a certain point, and now you need to run a test, because the next part of the calculation depends on what the current answer is. So you have to test the current answer. Okay, let me give you an example. If I want to calculate the sine of an angle, I could write 480 degrees. But for that series to work correctly in radians, I need to convert to radians between 0 and 2 pi. 480 degrees is more than 2 pi. So after I calculate the conversion into radians, I need to check that number. If that number is more than 2 pi, I have to subtract 2 pi from that number to make it between 0 and 2 pi. Right? Get the right number. If I go all the way around the circle, 1 time plus 90 degrees, what angle is that? Pi over 2, right? But it looks like 2 pi plus pi over 2. So it looks like 5 pi divided by 2, but that's not the number I can put in that series. I need to put pi over 2 in that series. So now in my algorithm, right, we didn't have this step before. In my algorithm, after I calculate a conversion to radians, I need a logic step. And that logic says, if the number you calculated is more than 2 pi, subtract 2 pi. Okay? What if I put in 7 pi over 2? Or 9 pi over 2? I need to do it again, right? So after that first logic statement, I have to test it again. If it's still more than 2 pi, subtract another 2 pi. Right? I need to get it between 0 and 2 pi before I can proceed to the next step. So I create this little logic flow in there that has to keep testing the number and see how big it is. And if it's above a certain value, it does one thing. If it's below a certain value, it does another thing. That's the logic control of how the algorithm flows through the program. You can use Boolean for that. The old-fashioned programmers love Boolean. Real people never use Boolean. Okay. All right. Any questions about that? was something from a lecture, I think it was, I thought it was one, let me see, I'm sorry, I wrote this down and then I didn't bring the paper. I thought there was one slide in there I wanted to say something about. Yeah, I just wanted to say, you probably looked at this. Okay, so yesterday I wrote a sequence of steps. I said, read, do the exercises, blah, blah, blah. So I just want to point out, it's in section 1.2. And I think this order is a little bit different from what I said yesterday because he says, he's got this as the first step, and I didn't mention this, but this is actually a good idea. So I'd like to emphasize it. So before you begin the lecture, skip through the slides and see if there's an exercise. If there is an exercise, read the exercise. Then you have an idea of what it is you're supposed to be learning from the lecture. So if you go to the end of the exercise and it says you're going to have to write an input-output statement, then when you go back and you look at the lecture, when he's talking about input and output statements, you know this is the thing you need to really pay attention to. Okay? So I just wanted to say that. All right, so now we're going to 2.1 was just on downloading. That was just to download C++. Did anybody try reading this yet?
Just read the slide.
Okay, running a C++ program. Okay, so here's his 5 steps. This begins, a minute ago I had things written across the board, but I had one more step at the beginning, which is that you understand what the problem is in the first place. So his steps begins with organizing the sequence of calculations. That's the algorithm. Okay, that's the part that we call the algorithm. All right, so now our first bit of programming. All right, so we talked about naming numbers. So we do that through the so-called assignment statement. So this example, who read this so far? Okay, no problem. So this is a simple example that we're going to calculate an average of 3 numbers. And for this example, he's not putting the 3 numbers in as input from outside of the program, like a user. He's building it into the program. So if you wanted to change the 3 numbers that you're going to average, you actually have to go and change inside the program. So we will update this in a few minutes so that it becomes a standalone program to calculate the average of any 3 numbers that you type in separately. That way you don't have to keep changing the program. The program will always calculate 3 numbers. You just have to tell it. Does everybody understand the difference? So logically, in one case, inside the program itself, that's what we're about to look at. Inside the program, we're going to calculate A plus B plus C divided by 3. But before we do that, we have a statement that looks like A equals whatever it is, 5, B equals 3, and C equals 7. Now, if I want to calculate the average of 3 other numbers, I have to go back inside the program and change these statements inside the program. Then I have to compile it again, and then run the program again to calculate the average of 3 other numbers.
Another way to do it, probably a better way to do it, is that for the program, you have first a statement read. It reads A, B, and C from outside. And then it calculates A plus B plus C over 3. He calls it A, B, G. That's fine. Okay? Does everybody understand the practical difference between these two programs? If I'm going to use this program, every time I want to average 3 other numbers, I have to go inside the program and change these statements. Then I have to compile the program again to change it into the machine language, and then it'll calculate the average. If I write the program using this logic, I can compile this into the machine language, and it's ready to run. But in order to calculate the average, it needs to read these 3 numbers from somewhere else. But if I put in the right kind of statement, it can do that. So every time I run this program, it stops and looks for those 3 numbers somewhere, then it calculates the average. But I never have to change the program. I just change the 3 numbers that I put in from the outside. So this is really an important difference in logic. Okay? So anyway, just to get this started, see, I gotta be a little better. Okay, so you can name the numbers whatever you want. A, B, C, X, Y, Z, first, second, third, number 1, number 2, number 3. You can give whatever name you want. You get to control that. Except, you can't give it a name that is an existing command name inside of C++. All right, so I've been using this example of calculating the sign. Actually, there's a function inside of C++ for the sign, because that's something people use all the time. So not everybody should have to write their own routine for sign. It's already in there. You can't use the name SIN. That's reserved for the function that calculates the sign. So that's an example of a name you can't use. But except for those function names like that are already in C++, you can give it anything you want. Calculate the average of Casper, find 3 people whose names are Alex, Celine, Catherine? Who's Catherine? You're Catherine. You're Catherine. Yeah, I gotta learn more names. I'm gonna work on that. Okay. The C++ variable names, they can start with a letter. You can put numbers in them, and you can put underscore. You can't put a blank inside them, and you can't put these kinds of special characters, because most of these special characters have a different control meaning inside the language. It's a way of controlling what happens in the program. The variable names are case sensitive. What does that mean? What does it mean to say it's case sensitive? Yeah, it means the uppercase, the capital letter and the lowercase letter are 2 different letters. This and this are 2 different letters. They're not the same. Right? This is big A and little a. So this is called uppercase. This is called lowercase. And C++ pays attention. Okay. He says recommend using lowercase. I'm not sure. I wouldn't necessarily agree with that. I don't know if it really matters, but I think use whatever you want. Okay, here are the variable types we talked about, and then we're going to manipulate variables through assignment statements and arithmetic. So really, in a sense, they're not different. But inside of this program, I let A be equal to 5. That's an assignment statement. B equals 3, that's an assignment statement. C equals 7, that's an assignment statement. The result of those 3 statements that I write in C++, when I run the program, what happens? Way over here, in the guts of the computer, in the hardware somewhere, A is set up like, I guess I erased it, sorry. A is set up like I showed you, the 6 digits. B is set up like that, C is set up like that. 3 separate places. physical places, real hardware places, exist over here that have the name A with the value 5, B with the value 3, C with the value 7. Okay, the next statement does exactly the same thing, except now we're starting to use some of the built-in functions, right? There's a built-in function plus, so we're going to calculate average. So first of all, the computer sets up another storage location for the thing called average. And then it comes over here and it pulls A out of its storage location. It pulls B out of its storage location. It adds them together. And it stores it in some dummy location. Right? Some temporary location. Then it pulls out C. It adds that and it stores it into a temporary location. Then it pulls out 3, well, it knows what 3 is, and it divides this location by 3, and that calculates the average, and now it writes that answer into the place called average. Okay? So now there are 4 things that exist in the hardware of the computer. There's a real memory location, and it's called A, another one called B, another one called C, another one called average. Okay? Any questions about that? That's the idea. Now, the difference with this program would be, instead of using 3 assignment statements to get A, B, and C, here's one of those commands, read, only that's not the exact name. We'll write the exact name in, which I don't think is logical. Fortran, for instance, uses the command read. That's why I wrote it, because I'm more used to Fortran. C++ uses a different word called, I think it's called cin or something. We'll see it in a minute. It's not as logical to me, but anyway, it's the same function. That function is, I can go to a different location where you've written these 3 numbers somewhere. Maybe on the screen you type them in. Maybe you've got a file stored and they're inside the storage. Maybe they're in an Excel file. You read it out of an Excel file. But somehow you tell C++ where to get these 3 numbers. So it goes to the place you told it to get A, and it puts it in there. It goes to the place where you told it to get B, and it puts it in there. C, and puts it in there. Okay? Same result, different logic. Any questions about this part? Okay. Simple C++ program consists of 2 parts. The initialization of namespace and header information. It's not really obvious why you need to do this, probably, to you yet, but I'll say more about it in a minute. The main program instructions, that's the part that you mostly do the writing. And now we'll see how these 2 parts of the program calculates the average. So, I'll just use this slide since they're well organized. But, I don't know how to pause it. Anybody remember how to pause? You get pushed backwards. Nope. Okay. The first command of all of your C++ programs has to be this statement right here. And I won't bother trying to explain why that is. It's just something that you have to have at the top of all C++ programs. The second command will have this form, but the names may change as to which ones we use. So what this one does is this is the standard command to set up C++, and this one brings in pieces of existing code that you're going to use. So C++ doesn't include all of its capabilities every time you run it. It has its capabilities in small subcategories, right, based on what functions they do, similar functions. And you have to pull out the pieces and tell it, I'm going to use these, I'm going to use some of these, I'm going to use some of those. If you don't tell it, it doesn't have them automatically. So I said a minute ago, for instance, it has built in a way of calculating the sign, S-I-N. Actually, it only has that built in if you tell it to include the library name here, the header file, the sub-library of functions that has the sign in it. Okay, now here's the part that you're going to write every time. So you start the main function. This is where you're writing your algorithm. You start it with int main. The command always looks the same, those 2 parentheses.
Again, I don't know why that is. Since everybody puts that at the top of every program, why doesn't it just know that you're going to do that and skip that? But it doesn't. You have to put it in. Then you put an open left bracket, and at the end, you always put a closed right bracket when you're done. And then all of your commands will go in the middle. Okay? The first command is to define the variables, to say which type of variable, everything that you're going to use. You have to have a list of everything you're going to use defined in the beginning. So A, B, C, average. You're going to use those 4 things. This statement tells it to use double precision. So it's going to store 12 digits for each one of those. Right? Double for A, B, C. Then these 3 assignment statements for A, B, and C. Then here's where you calculate average, and it stores average. And this is the output statement. C out. And by the way, in Fortran, it has the exact same logic. In Fortran, this statement is called write, W-R-I-T-E. You want it out? Write it. So to me, that's a more logical word, but it doesn't really matter. C out is the name, okay, in C++. System pause holds the output window. I'll say more about that in a minute. And it always ends with return 0. That's a kind of a crazy thing too, which we can explain later. All right, do you know how to pause this? Yeah, because it's going to keep going. Can you make it stop for a minute? Because I'm going to say a couple more things. You should go the other way. How do you get it to stop for a minute? I know there's a way. Does anybody know how to stop it? Well, now we can get it this way. Okay. Okay. All right, so I talked about syntax. Remember, syntax is if you don't write it exactly correctly, the computer won't know what you mean, even though it's really obvious what you mean. Right? It's not good enough for the computer. It's got to be exact. So you have to pay careful attention to how these statements are constructed. On the end of each statement, there's a semicolon. Semicolon is this thing. You need that at the end of each statement. On this kind of definition statement for a variable, you can list as many as you want on one line, but you can also have multiple lines. So you could have 4. You could have double A, double B, double C. Right? It just means you're typing the word double over and over again, so maybe you don't want to do that. Later on, we're going to see that we can set up something called arrays. Who knows what an array is? What's an array? An array is like a collection. Okay? So for instance, I want to average, let's say, 3 numbers in this case. Maybe there's no real point in calling it A, B, and C. We'll be able to set up a variable that could be A, and the size of A is actually 3 numbers. It's an array of 3 numbers, all with the same name. The first one is A1, the second one is A2, the third one is A3. Okay? If we do that, we can make double A as an array, and we don't have to write out so many names. So it doesn't seem like a big deal for this example, but remember the other day I talked about landing an airplane using an automatic landing system? And we agreed that maybe we're interested in 5,000 things. We'd like to know the position, the velocity, the pitch angle, the roll angle, the altitude. And we want to know that at 1,000 points of time, all the way from 8 kilometers out until it hits the runway. Well, who wants to type this? Who wants to type 5,000 names for all those things? That's crazy. So maybe what I would do is I would make an array that would have, let's say, time. And I'll make it 1,000 long. So now I have 1,000 variables that all have the same name, time. The first time is time 1. The second one is time 2. The third one is time 3, and so on. 1,000 actually isn't that much. I mean, a lot of real engineering problems can have tens of thousands, hundreds of thousands, millions. Okay. All right, so you can also double up these statements. Once you put a semicolon on the statement, the program recognizes that that statement is over. And then whatever comes next is the next statement. You can move these onto the same line if you want. So you could write this. This syntax is okay to write A equals 2, B equals 4, and C equals 7. And put it all on the same line. That's okay. You can even put the next one on the same line if you want. Okay, the good news about putting them on the same line is it can make your program look shorter. The bad news is, if you have a mistake on that line somewhere, the computer's going to flag that mistake. It's not going to work, and it's going to show you there's a problem on this line. This is where I'm screwing up. And the more things you have on one line, the harder it might be to figure out what the thing is you're doing wrong. So if you're making a complicated calculation, maybe like this, maybe you want it to be on its own line so that it's easy to tell that that's where the problem is. But for something like assignment statements like this, probably doesn't matter. Go ahead and put 10 of them on the same line. Okay, here's the syntax for the output. C out means write this on the computer screen. So if you're running this thing on the C++ compiler on your computer, it's going to write this onto your screen. You're going to see it on your screen. But that's not the only place you might want to write it. So there are different kinds of output statements depending on where you want to send them. Like in a lot of cases, you'll make a big calculation and you want the output to go into a file or maybe to the printer, right? Print the output, something like that. So there are lots of times when you don't want the output to appear on your screen. You want to hard copy yourself, maybe, or put it out on a thumb drive when you send it to someone. So we'll see those. There are different kinds of this output statement, but C out is for the computer. Then there's 2 left arrows in a row. Those guys. Okay, the next thing on the statement, it appears if you put it in this format, it'll show up as red on your screen to let you know it's a character. But basically, there's quotations. There's a beginning quotation and an end quotation. Anything you write inside of a pair of quotation marks, like that, gets printed exactly as it appears. So it's a way to put a label, right? It's not a number, it's not a value, it's just a number. It's just a label. So this would print something that says the average equals. It's going to print that every time. Now, what is the average? The average is the number that got stored way over in the hardware with this name. So we want to see what that number is. So the next thing on this list is AVE, average. This tells the computer, go to that part of the hardware and print that number right here. So now what will you see on your screen? You'll see the words that say, the average equals, and then you'll see the number that is the right answer. Okay? Anybody have a question with this?
So the red thing in the is what we want to see in the answer, and the ABE behind that is the calculation.
Yeah, the AV. If you could put this statement up here. Let's pretend we didn't bother to put the red thing in. What would appear on your computer screen is the number ABE. Okay, so if you remember what it is that you put in your output statement, you could skip this part and just see the number. So you run the program, and the number comes out. Let's see, what is it? 13 over 3. What is it? 4.333. Actually, yeah, here's a good idea. How is the answer of this thing? How would average appear when we print it out? This calculation over here. So AVG, when this runs on the computer, it's going to do 2 plus 4 plus 7 divided by 3. What's that equal to? How many 3s? Careful. Right? 5 would be right if it were float. But this one is double. Okay? But you're right. If it was float, if average was a float, there would be 5 3s. This is double, so there will be 11 3s. Okay? Yeah. Now, you can adjust how this appears with the decimal point too. You can play around with this. So by default, what some programs will always do is they always put a 0 first. So they would print this as 43333. There'd be 11 of them. And at the end, it would have something like e or exponent or something like that, meaning this is the power of 10. And then it would say 0, 1. So that tells you it's power of 10 times this. 43333. Okay? That's not very reader friendly. So you might want to play around with the format. We'll see how to do that. This command is going to print average using the default format that they always put numbers in. But maybe that's not the format you like. Maybe you'd like to see just 2 digits. Maybe you don't care about the other 9, right? So maybe you want to just see 4.33. That's good enough for you. You can tell I only want to see 3 digits. I only want to see 2 digits on the right side of the decimal point. Something like that. There's ways to do that. Okay, every time you put a new thing into the C output statement, you put another pair of those double arrows to the left. And you never put them to the right. So it's a little bit of an odd, in my opinion, it's a little bit of an odd syntax. Because usually when you write something, if you have this on one end, you put this on the other end. Or if you have this on one end, you put this on the other end. So this is a little weird. You put these 2 on the left side, but there's nothing on the right side. But if you want to keep adding things, you can keep adding them. All right, so let me give you a little quick exercise in class. You help me write this. I want you to help me write an output statement that would say, the average of, and then put in the 3 numbers. A, with a comma, B, comma, and then let's say and C is, and then put the answer out here. Okay? How would you write a statement that will print that on the screen when you run the program? What will the statement begin with? We're just going to replace this statement with a different statement that's going to print this way. Okay, C out. C out. 2 of these guys. Now what comes next? Yeah, you need the quotation marks. The average of. And you should probably leave a space in here. The space will get counted. Okay? And then quotation marks, right? And then what? And these 2. Then what? A. Not with quotation marks. Because I want to put the number up there. So I put A in here, it means the variable A. If I do this, it means print the letter A. I don't want the letter A, I want the value, I want the number that's A. So I don't mean that, I mean this. Does everybody understand that? Okay, good. Then what comes? More of these, and then what's next? Well, I like having a little comma in there to separate the numbers. That'll print a comma. Right. Is this cool or what? And B, comma, C, is, oh, and, yeah, I left and out. So this one, that should go in here, sorry. So a comma and, all right, that could be all part of the same stretch. C is, A, we,
Yeah, BVE. Okay? At the end of one of these lines, you put two more of these guys and then ENDL semicolon. That's just part of the syntax. How cool is that? It's really cool. Does anybody have any questions about that?
See why it's different. We have the average of the underline. So I think we should put some letter not there.
Well, yeah, you mean these underlines? I wasn't trying to put the underline in the statement. I was just telling you what I want to go in there. Yeah. How could you get an underlined number into the statement? I'll just tell you it's possible to do that, but let's not worry about it right this minute. Okay, did everybody hear his question? Because it's an interesting question. I mean, if you're the programmer, you want your program to be beautiful. Maybe you think this program would be more beautiful if, instead of just writing the number here, now the output of this statement is going to have the whole number A here, the whole number B, but they're not going to be underlined. I just put an underline there to show that's where I want A to go when I asked you the question. But let's say that you decide I want to print this thing and I do want that number to be underlined. It turns out there's more commands you can stick in here that will print it with an underline underneath it. You can make the output even fancier than what we're doing. Yes?
If I want both the statement A, B, C, and the variables, so how can I do it? That means I want to the ABC appearance.
Yeah.
As
characters?
A, B, and C.
Yeah. How do you make something appear as a character?
With the potential mark.
Yeah, with quotation marks, right? So you could say, let's change the statement a little bit. Yeah, how should we? I'm just trying to dream up an example that would do what you're saying. But you could have a statement that says something like, let me write one. I'll tell you what, I'll write a statement and you tell me what it said. Okay? Yeah, how about that one? So when this actually executes, when we run this program, what will be the output of this command? We will write this as the average of A equals 2.00012, right? Comma, B equals, is it 4? Yeah, 4.012, comma, and C equals 7.12, right? Comma, is average equals 4.33. That's what will appear. I didn't put C in here, I made a mistake. C. Yeah. That's the kind of mistake that's really easy to make. Right? Get in the middle of the statement, you leave out what you're there. So that's the debug part. When you would run the program without that C in there, that command would work. This is one of those commands where there was no syntax error. There was a logic error. So I forgot to put this in the first time. If I forget to put this in, what's different about this output of the statement? There would be nothing here. So I might have this statement in here by mistake. It runs fine. There's no error. The computer doesn't have any problem with this. It'll print the statement. Then I look at the output and I say, what the heck's going on? It prints A, it prints B, it prints the average. Why doesn't it print C? So this can drive you crazy because you might not notice that you just left out two little things. Okay. Any questions about it? Now, one thing about the C++ compiler that is a nuisance, I think. The computer output screen that it writes into is an old DOS screen. We talked about DOS yesterday, Disk Operating System. That's a really early version of an operating system that came before Windows. And back in the old days, I remember this very well, computers were not color. And there were not fancy fonts, they weren't different sizes. It looked sort of like a typewriter. In DOS, you have a black screen, and you get white letters, and they're not fancy, they're not nice. And that's the C output, that's what it writes into, a screen like that. Okay? So sorry. If you want to make your output look more beautiful, you need to write it to somewhere else, which you can do. We'll see other kinds of output statements. Write it into a different file, for instance. Okay. Are there any questions about this? I think this is I think this example, I hope, is really helpful to get you started.
If we go like A, the 2, B, 4, and C7 at the top, then this will come out with a random number.
No. That's a good question. He said, the question is, if we don't define these variables, let's go in order. Maybe what we can do is actually run this in a minute. We'll see what the actual commands are. But just the logic is, if I don't define these variables, and the first statement it sees is A is equal to 2, I'll get an error. The computer will give me an error. So, yeah, let me describe. We put up these nice logical steps that you use in writing the program. One of those steps was debug. And I said something kind of casual about debug. Debug sometimes is nothing like casual. Debug can be an enormous pain in the ass. You write a program, you spend hours, days, weeks, months, years inventing a beautiful algorithm that's going to solve the world's problems. You write it all out in 1,000 lines of code, and now you go to run the computer, and it doesn't run. It gives you an error on line number 2. You scratch your head, you finally figure out what's wrong with that one. You try it again, it gives you an error on line number 4. And 2 weeks later, you're down to line number 75, and you've still got 3,000 lines to go. That's more realistic for debugging. Debugging can be really nuisance. So, back to this thing. This program, the way it's written, is correct. This will run. But if you left that line out and you try to run it, it won't run. But one nice thing about the C++ compiler, it does a pretty good job of giving you an error message that you can make sense out of and telling you where the error is. So, for instance, if you took that out and you tried to run this, you'll get a message that says something like variable A is undefined. Now you know you have to come back up here and define A. It's a double. In the early versions of Fortran, error message. Fortran, by the way, remember yesterday we were talking about base? Fortran is used for base 16. Okay, talk about a pain in the ass. Let's try writing the number 1,000 in base 16. So what does that mean again? Let's practice. So in base 16, the first place would be the numbers between 1 and 15. Right? The second place would be the number of 16s. The third place, 16, what's 15 times 16 is 160, 80, 240. So this would be the number of 240s. The next place would be the number of 15 times 240. It's 2,400, 1,200, I think, 36, 3,600s. Okay, everybody knows how these bases work. We talked about it yesterday. Yeah, what a nuisance. What an enormous pain in the neck this is. In fact, there aren't even enough numbers in each column, so Fortran uses letters. So in this first position, it could be 1, could be 2, could be 3. They mean exactly what you think they mean, up to 9. But after 9, there has to be something that represents 10. They use A. There has to be something to represent 11. They use B. All right, so let's try writing the number 1,000. So for 1,000, I don't know if this is a good example or not, but let's see what we get. So for 1,000, we don't need these, but we are going to need some of these guys. So 240 will go into 1,000 4 times. So we have 4 of those. That gives me 960. Now I need 2 16s. No, yeah, 2 16s. That will give me 32, so now I'm up to 992. And I need 8 more. So that's the number 1,000. But let's do 1,000, I don't know, I'll do 1,005, 1,007. So 4 240s is 960. And then I need 47 more. That's only 3 16s. Sorry, it's only 2 16s again, 32. And now I need 15 in here, which would be A, B, C, D, E, F. So there, that's the number 1,007 in Fortran. Okay, it was horrible. Okay, now here's what's really horrible. You can do something silly like you leave this statement off. So this is the first statement it sees, and it says, oh, you didn't tell me what A is. So the error is you didn't define A. Okay, what the Fortran compiler would write is something like this. What the hell does that mean? No idea. So, believe me, back in the old days with the Fortran compiler, people would spend years trying to figure out what was wrong with the program. Even simple errors were impossible to figure out. So one of the great advantages of later versions of Fortran is somebody took the time to convert these kinds of error messages into words that make sense to human beings. Like, you forgot to define A. Okay, I understand that. Okay, any questions about this? You still will have some errors. I bet before this course is over, you'll come across a few error messages that you'll wonder what the heck does that mean. Even though they're supposed to be easier to understand now, they're still not all perfect. Okay, so if you start out C++, did everybody try this? Have you started it up at home?
Yeah.
You could, that program that we just had on the board with different C output statements, you could run that right now if you want. Just go ahead and start running C++. In this presentation, he talks about closing this box over here because we're not going to use it. So just get that out of the way. It doesn't really matter if you know. Then he talks about the different submenus. It's like a lot of other Microsoft products, right? Application programs. You can find all kinds of different submenus. Yeah, down at the bottom, it's nice to know. If you do have errors in your statements, you get those messages down here at the bottom. That's where it tells you forgot to define A or something like that. Okay, so let's say that you're going to go home and write your first C++ program. Do something exciting tonight. What's the calculation that you'd like to make tonight? In a way, it's too bad you didn't have this course at the same time as 208. Because you had a lot of homework in 208 where you had to calculate something, right? So you could have been writing these programs to do your 208 calculations. That might have been fun.
I think it's some
Yeah, summation. Okay, so here's the average program. He's typing it in here. Yeah, you can get rid of this side window. That's easy to do. Inside of View, if you click on View, what you'll get, like a lot of programs, you'll get a list of things that may appear if you want them to, and beside them you put a check if you want them to appear. So he just took the check off of that one so that the whole screen now is just for statements. And here's the average program. One nice thing about C++, the different types of statements have different colors. So inside of the C++ compiler itself, the colors are very helpful. It's good to remember what they stand for. It'll help you figure out what you're looking at. So red is characters, right? Purple is numbers. Green is the so-called header file that you need. We'll say more about it later. And bold, special things. So up here, this is compile. Compile is when it does the conversion into the machine language, zeros and ones. So it doesn't run the program, it just compiles it. Now, most of the time, if you're going to make a relatively short calculation, like this one, there's no reason to do this as two separate steps in my opinion. So if you look at the top here, this is compile. Next to it is run. And next to that is compile and run. Alright, so he clicked compile by itself and did the compile all by itself. But you can click compile and run and do them both together. Okay, we need a little more quiet in here. Right. Again, I don't mind if you want to talk, just not in here. Alright, so did you see the error? It gave us an error because we didn't put the semicolon at the end. So here's the message down here. It expected a semicolon before B. So here's what happened on that one, so that you understand, so that it's easier to interpret these later. You have to put a semicolon at the end of the statement to let it know it's the end of the statement. You don't have to have the statement on one line. So those two statements together look like this. He had A equals 2, and underneath B equals 4. And the semicolon, but he didn't put it on the A. How does the compiler interpret this? It sees a statement that looks like this. It doesn't make any sense to it. For one thing, there's two equal signs, right? An assignment statement only has one equal sign. Also, 2b doesn't mean anything. You need to have an operation in there, like multiply or divide or something like that. You can't have a name that begins with 2. So 2b can't be the name of something. So the computer didn't know what to make of that. So you couldn't decide what that was. Now here's a version of the same kind of mistake that would drive you crazy. Right? You could have a program, maybe you have something like this. C equals 7, then you could have A equals C, and B equals 4. Now what the computer sees is A equals CB. If you have another variable in there that's called CB, the computer might interpret this correctly and make A equal to CB. That's not what you intended. So that's the kind of error that might not actually get identified as an error. All right, let's can we pause it again here? How did we do that last time? Push it back or up? No. Lost it. Let me go back. Yeah, so here are the error messages. So when you do there's the compile button, the run button, compile and run. In my opinion, the only reason not to do compile and run at the same time is because the program is really long and it would run for a long time. So you don't want to start it unless you're pretty sure it's already right. So then you do the compile by itself first. But otherwise, you will run it too if it'll run. When you do the compile step, it prints the errors down below, and you can see what the errors are. So this identified 3 separate errors. Let me see that. Can you read that? Left out
in function. Yeah, here was on the screen. I think he left out the semicolon on this first statement. He left one out there, B. And the last one is, yeah, so I can't read it. Expected, oh, yeah, he left the end bracket off at the bottom. Yeah, so he's pointing to each one of those. Okay, the system pause command, I didn't say anything about that a minute ago, but it says system pause. So what DOS does, it's the old operating system, remember? When you print the output statement into DOS, the DOS window normally will only stay open for as long as the program is running. So if it successfully gets to the end of the program, it shuts that window down. If that's where you're printing the output, you don't want that to happen. You want to be able to see and see what the answer is before it shuts down. So this command here, it says system pause. That will hold the DOS window open even though the program finishes. And then what you can do is, inside of that window, if you press any key, that releases the pause and the window will shut down. So you go into the DOS window itself. Does everybody understand that? So again, it's a little bit crazy. It shows you how old this is. This goes back to really old times. This was the beginning of this program. And some of the things they haven't changed. But the output of that cout statement that we've been writing, it goes into a new window that's a DOS window. It's a different operating system. And that operating system will shut that window down as soon as the program quits running, unless you tell it to stay open. And usually you want it to stay open because if it shuts it down right away, you won't know what it is. Right? You won't see your answer in time unless you're a really fast reader. So that's the statement here. System pause. And I think this runs. And he shows you what the output looks like when you run it. That's the compile. That's the run. There's a DOS window. That's what DOS looks like. Black, white background, simple white. So it says the average equals 1.3333. That's the output of this cout command. And then it says press any key to continue. That's the output of the system pause. Yeah, this is more about changing the look of the screen. I think it's not critical. It's up to you whether you want to do that. But some of the functions that are on these sub-menus we probably won't use in this course. So you could just go ahead and close those sub-menus down so there aren't as many of them, but I don't think it really matters personally. Okay, so you can have, everybody should create somewhere in a place that you'll know where it is, a folder that you can put all your C++ programs in. And then you can call them out whenever you want them. Okay, so you open a file in here, just like you do in most MATLAB programs. If you press the file, you get an open option. If you press open file, then you can pick wherever it is on your computer that you stored it. You select one and then it'll open. You can have multiple programs open at the same time. So you might find as you go through the exercises, the homework, and the projects, you might write sections of code, like say certain output statements that are really long, like the one we had up here a minute ago. It's kind of a nuisance to write it over and over again. You might want to cut statements out of one program and paste them in another. It's no problem. You can have multiple programs open, and you'll see a little tab for each one. Okay, but if you happen to click the run command or the compile command, that only happens to the program that's on top right now. Then you have to click on the tab for the other program if you want it to run. Okay?
Yeah, so I'm going to talk about subroutines in a minute. Okay, so here's some programming examples. I think you have these already. They were on that disk, so you can look at them. There's 3 different programs. So what you should be able to do right now, maybe you've already done it, you should create a folder somewhere on your computer that you start putting all your C++ programs in, and I would recommend making subfolders so that you can keep them organized. Go ahead and put these into one of the subfolders. Then you could open the C++ program on your computer and put all 3 of these files in and have all 3 of them ready to run at once. And practice clicking on the tab for one and run it, click on the tab for the other one and run it. Then you should go into one of the ones that has the error. Like the second one has some error in it. Edit the program. See how that works, right? So that you know how to fix the program and then how to resave it so that you're ready to run the corrected program. Because you're going to need to do all of those things on all of your homework problems, unless you get it perfect the first time. Work on exercise 2.2. Okay, so now I want to talk about something called subroutine. These have different names and different software. Sometimes they're just called functions. In MATLAB, they're often called just plain old M files. But typically what they are is, it's a piece of a program that you may want to use in many other programs. Okay? So let me give you another example, a very simple example. The sine function. So we talked about that before, right? So I started with the example that suppose your calculator sine button is broken. So every time you want to calculate the sine, you have to go through those steps to calculate all those 30 button pushes or whatever it is. Well, why do you have a sine button on your calculator in the first place? Because you use the sine a lot. People use the sine a lot. So a sine function, the thing that's underneath that button on your calculator, that's an example of a subroutine, or a function, or an input. And because you're going to use it over and over again, you create it in such a way that you can always call it independently from lots of other programs if you want. You don't have to keep rewriting that program over and over again every time you want to use it in a different program. Does everybody understand? Okay, so the idea of a subroutine is that it's some piece of logic that you know that you might use more than one time. And instead of always taking those commands and sticking them into every new program that you write for the rest of your life, you create your own function. And so in a sense, you've increased the capacity, the ability of C++. And now you can just call that as a subroutine, as a name. Right? So maybe I make up a subroutine and I decide I'm going to call mine Joe. And Joe calculates how to make $1 million. Okay, so that's something I'm going to want to use in a lot of other programs. So I can set that up inside of C++ as a separate file. But I do it in such a way that maybe now I'm writing another program called TED again. And TED has all kinds of commands, thousands of commands. But buried in there along the way, I want to calculate the same thing that Joe calculates sometimes, as an intermediate step. Not the whole calculation, but some part of it. So wherever I need to repeat all the calculations that are in Joe, I can just put Joe in there, and it uses it like a function, just like sine, right? Or logarithm, or something like that. So that's the idea of a subroutine or a function file. And I'm mentioning that now because when you're organizing your folder with your C++ programs in it,
you might think about putting some of your programs into a separate subfolder of things that you think you will be using over and over again. Like maybe you're really good at writing those output statements. You like to have a nice, beautiful output with a lot of words that labels everything. So after you write a few of those, you put them in a subroutine, and that becomes your new output. So now, when you go to write an output statement, instead of doing C out and repeating everything, maybe you've defined the statement. Instead, you've got a subroutine, called whatever you call it, Fred. Now, instead of using C out, use Fred. When you type Fred, it prints this beautiful statement for you. You don't have to type any more than that. Fred remembers everything that was in that long C output, maybe some other ones too. Okay. Okay, so probably it's a good place to quit. For tomorrow, so we did 2.2. So for tomorrow, why don't we try to do two of them? Let's try to do 2.3 and 2.4. Okay? And remember, you're going to look at the exercises that we just passed exercise 2.2. We didn't do it. I'll tell you what we can do, though. Why don't we take them together? Let's look together what this exercise is and see if you think you're ready for it. Okay, so this exercise says to open up C++, create this program by typing it in, save the program with that name, compile the program, run the program, and make sure it works. Okay? I think everybody's ready to do that. Anyway, that's just practice on how to actually type things into the program and save and that kind of thing. Then the next thing, you need to modify it. Okay, modify it so it has some kind of syntax errors. Remember, syntax errors, you don't use the form of the statement correctly. So maybe you forget to put the semicolon on the end, something like that. So he did examples that showed 3 syntax errors. Make up some of your own syntax errors. Okay, put them in there. Things that you think you might screw up. Try not defining the variable, for instance. Don't put the double A at the beginning, just put A and see what happens. So the idea here is to get some practice with understanding what the errors are, because you put the error in, so when the error statement comes back, you know what it's talking about. It's better than having it the other way around, where you're not sure what the error is, and then you get a statement, and all of a sudden you don't know what the hell it is. So this will give you a chance to practice getting errors when you know what the error really is. And then you can organize the exercise files on your computer. All right, this one I think is too easy, so let's see what the next one is. I want you to do this. You should do this. But let's see if we're already ready for the next one. 2.3. Okay, you're going to write a program to calculate a volume. So this is going to calculate the volume of a pyramid. All right, so here's where you're going to begin to write your own algorithm. You're going to have to figure out the logic of the calculation and then turn it into the correct syntax. So the first thing is to calculate the volume of a pyramid. Right? If you have the base and you have the height, the volume is equal to 1/3 of the base times the height, the area of the base times the height. Then you have to modify the program so it will also determine the dimensions of an optimum cylinder that contains the same volume as the pyramid. An optimum cylinder is one that has, as its height, equal to its diameter. Okay? So you got to go figure out how to do that. Print the value of the cylinder height and diameter to the screen, as well as the initial height and base input of the pyramid and the pyramid volume. So you're going to be printing 5 things and label them, all labeled appropriately. So put the character values in, height of the cylinder equals, volume of the pyramid equals, something like that. Any questions about that?
Good little challenge. All right, and then run other examples. I guess that's something else. Run the two other examples from section 2.3. You've got them already. One called number operations, and the other called variables. Right, so just run those two examples and play around with them. But this one right here, these two put together, especially this one, this will be your first challenge to come up with your own algorithm and write a program that is successful. Okay, questions? Have fun. See you tomorrow at 1 o'clock. Do lecture 2.3, 2.4.